Well, hello and Happy New Year. The new year saw the arrival of these one-way clutches, so this is the next experiment in the quest for a self-sustaining pendulum. And in the interests of jeopardy, the final result will only be revealed at the end. Now, as mentioned last time, these sprag clutches look just like ordinary bearings, but they are very clever pieces of engineering. They immediately brought back memories of my first and only encounter with them 50 years ago, and just like playing with magnets, there's some sort of magic about them as their behaviour seems so counterintuitive. If you hold the inner cylinder, the outer ring rotates smoothly as you'd expect, but only in one direction. If you turn it the opposite way, the inner cylinder turns as well. Now, the changeover is uncanny. There's no obvious transition, it just locks solid the instant you turn it. There's an arrow on the inner cylinder to show the orientation. So now the question is how to lock it securely to the conrod and motor shaft. Now, I chose the version with both inner and outer keyways to keep my options open, but in the end these were not necessary. The conrod was fairly easy, as it just meant cutting a hole such that the outer cylinder is a tight press fit. Here's the new conrod, very much simpler than before, with no sensor arm or driver bar as with the previous attempt. The motor shaft was more tricky, as I did not want to push fit here, as it needed to be detachable for ease of assembly, and in the absence of a lathe or a 3D printer, some improvisation, aka bodging, was needed. So engineering purists, look away now. I found a standard CNC shaft coupler which fits onto the motor shaft with grub screws, and its outer diameter matched the clutch's inner cylinder, so the plan was to glue the coupler inside it. Now, as it happened, the coupler was a smidge too big, which was good news as it meant it could be made a tight push fit if I could reduce the outer diameter somehow, which is where the poor man's lathe comes in. I clamped a file in a vise at 90 degrees and fixed the coupler into the CNC motor spindle using a small rod. Now, I forgot to video this, and I only had one coupler, so this is an artist's impression. I switched on the motor and pushed the file against the coupler. When I'd taken enough off, I pushed the coupler into the clutch using a bench vise as a press. Not exactly precision engineering, but perfectly adequate for this. And the whole assembly can now be attached or removed from the pendulum motor as needed. You can see the clutch working here. As I move the conrod back and forth, the red coupler, which is the motor shaft, only rotates in one direction. Okay, so now to fit it all onto plate 4. Now, this needed recutting as the old version on the left had been through many different designs and was looking like a Swiss cheese. The 4 black spaces hold the rotary sensor module, very similar to the motor hand sensors shown earlier, and the 2 brass spaces rotate with the conrod, and these hold the sensor magnet. And just a few more parts to cut. The 2 bars at the top are for the sensor module, and the bottom bar holds the magnet. First tests with the small pendulum and a 260 gram weight as the bob, and it appears to be a definite improvement on the previous design. And one advantage with the clutch system is that it does not matter if the motor stalls or runs backwards. It won't affect the pendulum. And as soon as the motor moves forwards, it's guaranteed to push the conrod immediately, no matter where it is. So there's no uncertainty with the timing. This also means the motor can use full steps and benefit from the full torque available. So finally, does it work with the big pendulum? Cue drum roll. The swing builds up much quicker than I thought, so there's plenty of power, especially as it's wasting some of it by only pushing every other swing. And there's obviously an issue with this software algorithm, but I'm confident this can be fixed. The bottom line is that it confirms the whole stepper motor idea is viable at last. I'll post any more developments as and when, but meanwhile, hope this was interesting and thanks for watching.